This is part 2 of section 6.3. We have been working with special factorings. So I am given 9y squared plus 6yz plus z squared, and I want to get this factored. Now, I know I am in the special factoring section, so just using logic, if you look at all of these, the only one that allows for 3 terms are perfect square trinomials. So while you are within this section, this is pretty easy to identify. But of course, that doesn't happen in real life. These will be mixed in with everything else. So let's talk about how to recognize what we have. Okay? So our first step is to factor out a GCF if we have one. I have a 9 here and no number here. I have a Z here and no Z here. So there's no GCF. Okay? I don't have 4 terms, I don't have 2 terms, I have 3 terms. So we get asked, do you have perfect squares on the ends? What that means for us is we look right here and right here. And this is a step you can usually just do in your head. Is this a perfect square? Well, yeah, its square root would be 3 and a y. Okay? Z squared, is that a perfect square? Yes. Its square root is z. Okay, if you have perfect squares on the ends and a plus sign right here, it is definitely worth checking to see if you have a perfect square trinomial. And the way you check that middle term, okay, so right here, I can see that I have a perfect square on the end, so that fits both of these. I have a plus sign here and a plus sign here, so if anything, I'm using this first formula. Okay, what I need to check is this middle term. I need to make sure it fits this pattern. And the way we do that is you multiply these two things together, which will give you a 3yz, and then you double this, so multiply it by 2, and you get 6yz. Now ask yourself if this is the same as this, and it is. So if these two things are the same, you get to factor it as, look right here, this is squared, here's the square root of it. So that's going to be a 3y. Your middle sign always matches this sign. So if this is a plus, this is a plus. And then the square root of this, which is z, and then squared on the outside. Now, like I mentioned earlier, you can do this learning what we using what we learned in section 6.2. You can multiply these together, look for 2 numbers that multiply to 9 and add to 6, replace the middle term, factor by grouping. You would end up with 3y plus z times 3y plus z. And I expect that you would recognize that this can be rewritten like this. And you probably need to slap yourself on the forehead because you did it the hard way. Okay? All right. So let's try 80z squared minus 40zw plus 5w squared. Our first step is to always factor out a GCF. When I first look at this, I see that I have 3 terms. And the first thing I kind of check is just like looking ahead to see if I have perfect squares on the ends, and I don't. But I notice my numbers end in 0s and 5, so I can factor out a 5. My GCF is 5. When I factor that out, I get 16z squared minus 8zw plus w squared. Now I had to do that much no matter what. Okay, now I need to see if this will factor further. I have 3 terms. I notice I have a plus sign here and that these two things are perfect squares. So I ask myself, what is the square root of 16z squared? Well, that would be a 4z. The square root of w squared would be a w. If I multiply these two things together, I get a 4zw. And then if I double that, I get 8zw. Does this match this? Yes. That means I have a perfect square trinomial. And since this is a minus, I'm going to use the minus version right here. So my answer will be 5 times 4z minus w squared. And that is my answer in factored form. Okay, now all of those we could use 6.2 on. Now we're into things where we cannot. Okay, let's look at z cubed plus 125p cubed. Do I have a GCF? No, there's no coefficient here. Well, the coefficient here is 1. I don't have a z here, so there's no GCF. I do not have 4 terms. I do have 2 terms. Is there a plus sign in the middle? Yes. So I'm going to check to see if it's a sum of cubes. If it is not a sum of cubes, I cannot factor this. Okay, so I need to ask myself if these numbers are perfect cubes or not. Okay, so let's look right here. Is z cubed a perfect cube? Yes. Its cube root would be z. Is 125 a perfect cube? Yes, if you look back at your list, 125 is 5 cubed. So its cube root would be 5. The cube root of p cubed would be ap. All right, so let's look at our formula here. Okay, I have a sum of cubes. I need to figure out what to use for a. I need to figure out what to use for b, and then I can just plug in everything. Okay, so I am going to use z for my a, and I use 5p for my b. And I'm just going to follow this pattern exactly. You will get to where you can do the simplification in your head, but don't worry about that for a while. This is going to factor as a plus b. So my a is z plus my b is 5p. Okay, times a squared. Well, my a is z, z squared minus a times b. So this is going to be z times 5p plus b squared plus 5p all squared. Okay, I've just written out every step here. Like I said, you're going to end up probably doing some of the simplification in your head. There's nothing to simplify here. It is z plus 5p times z squared minus, this is better written 5pz or zp, that order doesn't matter, plus, now remember when you have things multiplied together, raised to an exponent, you need to put the exponent on each of these. So 5p squared is going to be 25p squared. Okay, this is not going to factor any further. And so this whole thing is your answer. That is it in factored form. Okay, so let's try 250 minus 16y cubed. Okay, so I have 250x cubed minus 16y cubed. I see that I have a minus sign and I see cubes here and here, but 16 is not a perfect cube. It is a perfect square, and 250 is not a perfect cube, nor is it a perfect square. So if I start looking ahead too far, I get confused. But what is our first step always? To factor out a greatest common factor. I see that both of these numbers are even. That means I can factor out a 2 at minimum. So let me do that. If I factor out a 2, I get 125x cubed minus 8y cubed. Okay, so I double check here. I don't have another GCF, so 2 is the largest thing possible. I have two terms with a minus sign, so I'm hoping it's either a difference of cubes or a difference of squares. Now, x cubed, y cubed, definitely not perfect squares. I need to check if 125 and 8 are perfect cubes, and they are. The cube root of 125x cubed would be 5x. The cube root of 8y cubed would be 2y. So when I'm using my formula, all of this is going to be a, and all of this is going to be b. We cannot lose the 2, it just travels down with us. So bring down that 2 times. Okay, this is a difference of cubes, and it works exactly the same way as this one did. You're just going to have, your signs are going to differ just a tiny bit. Okay, so with a difference of cubes, you do a minus b. This sign matches this sign. So this is going to be 5x minus 2y times, okay, a squared. Well, a squared is going to be 5x squared, which is 25x squared, because you square each piece. So 25x squared plus, multiply these two things together, a times b. 5x times 2y is going to be 10xy. The next sign is a plus. And then you figure out what b squared is. That's 2y all squared, which will be 4y squared. So, all right, I should not have parentheses right there. I'm going to rewrite this to get 4y squared. And I'm sorry I wrote it badly. Let's try it again. 2 times 5x minus 2y times 25x squared plus 10xy plus 4y squared.